more of the board.
What? She told me I didn't have to do mine.
Hello. Okay, all we have to do today is go over the homework problems, and we should be ready for tomorrow's test.
I'm gonna see it.
You don't know the math meet is this Saturday. You don't know the test is tomorrow. Everybody else knows. Chai, what's going on? Look, even Hanaoka knew. Oh boy. Why is there only one 3D eraser here? Funny. Okay, number 4. Okay, I'll tell you right now. Problems 1 through 8. Problems 1 through 8 on matrix 5. These are the 8 problems on the test. I don't know what more I can tell you. So that means you're not going to use a graphing calculator to solve 6 equations, 6 variables. I'm assuming you know how to do that already. Since you have to do it on your homework. Okay, now number 1. Now number 1 on tomorrow's test, I'm going to be nice. Instead of asking you to solve the whole system, in other words, you don't tomorrow read the directions now. You don't have to find W, X, Y, and Z. I'm only going to ask you to find one of them. Okay? So tomorrow it might say number 1, solve for Y using Kramer's rule. Now, if it's up to you. If you don't read the problem, I'm telling you now, because every year there's always 2 or 3 people, they end up finding all 4. And that's just a waste of time, right? I'm only going to ask you to find one. Do you understand that, Chai? This week you seem like you don't know anything. See? Maybe that's why. You're not paying attention in class. So that means tomorrow, number 1, you only have to compute 2 4x4 determinants instead of 5. But each one is going to be all or nothing now. That's the way it is. 4 points for, so if I ask you to find y, so how do you compute y? Y is d sub y over d, right? So this is 4 and this is 4. And of course, if you divide them wrong and get something wrong, you take up an additional point. You could lose up to 9 on that one. No, because you could go, 8 over 2, 6. And that would be a minus 9 if both of these are wrong. Now, every year, students get the wrong sign. He said, oh, Mr. Park, you only got minus. That's because you forgot the plus, minus, plus position thing, and that's why you deserve to get minus 4. That plus, minus, plus thing is super important. Okay, we understand number 1 now. Okay, let's go to 4. No, come on. Okay, you should be happy you get this problem on the test. This one's easy. Are these matrices or determinants? They're determinants, so you just compute each one. So this one, should it generate zeros or should it just compute it? Yeah, just compute it. I like to go across the first row. So it's going to be x times x squared minus 3. Just compute it, don't even think. Minus 1 times 3x minus 2 plus 2 times 9 minus 2x, right? I hope we know how to compute determinants by now. And then this one's a 2 by 2, so this times this minus that times that, so that's 4 plus 2x. All you have to do is solve this equation. Okay, so you write this out on your paper, I give you 2 out of 8. You want the other 6 points, you gotta solve this equation. So multiply out everything, you get x cubed minus 3x minus 3x plus 2 plus 18 minus 4x minus 4 minus 2x. How come I'm making one side 0? Because that's how you solve an equation if the degree is 2 or bigger, right? You make one side 0. So you got x cubed, what is that, minus 3, minus 3, minus 4, minus 2. Is that minus 12x? And then I got 2, that's 20 minus 4, so that's plus 16. Equals 0. You're the person, every time I go to the movies, there's always one person behind me. And then you give them the look, and they still do it. And then you give them the throat thing, and they still do it. Okay, do you remember how to solve third power? Synthetic division. Or, oh, okay, you guys want to do factor by grouping? I'm up. I'm game for it. Okay, so factors of 16 over factors of 1. 1 doesn't work, so the next logical choice would be 2. So 1, 2, 2, 4, negative 8, negative 16, 0. Yeah, I can see that. So x minus 2 is a factor, and then we look at the coefficients here. X squared plus 2x minus 8 equals 0. Now, is that factorable, or do I have to use quadratic formula? It's factorable, so that's x and x, 2 and 4, plus minus. So what are your 3 answers? 2 and negative 4. 2 is a double root, yeah, but you don't have to write it, but you just gotta know it's a double root. Because remember, when you have a third-degree polynomial equation, there should be 3 answers, right? It's just that 2 is a double root, because the graph bounces off, that's why, right? See, it's very mechanical. There's really no thinking. Number 7, 8, and 9. Are you joking me? Is this April 1st? Didn't we just do this yesterday? Well, in order to do number 7, you got to do number 6 first. Okay, can I assume we can do number 6, or shall we just do it one time just to make sure everybody got it? Okay, let's do it. This is on the test now. I'm going to give you a matrix. It's going to be 3 by 3. I'm not going to kick it up a notch on this one, on this particular problem. You have to find the inverse. Okay, now there's only 2 ways of finding inverses. Either you do the A, B, C, D, E, F, G, H, I method, which I'm sure you don't want to do, or you use that thing that I taught you, which is what? What's the first step? Replace each element with its cofactor, which means you got to know the negative positions. So I'm telling you right now, put the negative on the negative positions right now at the beginning. See what I did? Because that could cost you 6 points right there, just by getting the wrong signs. In fact, I'm telling you right now, you don't put that, it's minus 6. Okay, now, all you gotta do is replace each element with, so cross out the row and the column, so like that. Negative 3, minus 3. So this upper part, cross out the row and column, and you got 6 plus 2 is 8. Upper right hand corner, 6 by 2 is 4. This one over here, cross out the row, negative 3 minus 6 is negative 9. The middle one will be 9 plus 4 is 13. And that one over there will be 9 minus 2 is 7. And then the lower left hand corner, negative 1 plus 2 is 1. And then 3 minus 4, negative 1. And then negative 3 plus 2 is negative 1. So just keep crossing out the rows and the columns. What's the next step? Transpose it. So the first row is now the first column. The second row is now the second column. And the third row is now the third column. And then you need to multiply that by 1 over the determinant of the original matrix. Now, I don't care how you compute it, you just got to do it. So this number there, that's like 3 or 3, I don't know how many, 3 or 4. Okay, make it 4, whatever. Okay, so I don't want to reinvent the wheel. These are the cofactors right here. So pick any row or column, pick one.
First row.
Okay, first row. Just multiply this times this, that's negative 18. And this times this is 8. And this times this is 8. Add them up, negative 2, that's the determinant. Because these are the cofactors. This is a inverse right here. This is A inverse. Box that, that's the answer. Do I have to put the negative half inside? No? Wait, let me look. No? That's that. If you want to put the negative half in, you're welcome to. But why? You don't have fractions in there. You have to keep it out. Okay, so that's full credit for part number 6. Okay, now, look, in my answer, look. I kept it out there. And you guys wondering when. Now, number 7, this is probably the easiest problem going to be on the whole test tomorrow. Use the results from this problem to solve this 3 equations, 3 variables problem. Do you notice the coefficients of the variables are the same thing as this? Is that going to be it tomorrow? Yes. And for those of you, I don't know, whatever. Okay, so how do I solve this system using the inverse? What do I do? Remember, AX equal B is the matrix representation, so to solve for X, you multiply by A inverse on the right. This is how you solve the system. So all you do is you take A inverse, which is this, -6, 9, 1, -8, 13, 1, 4, -7, -1, and you multiply it by matrix B. What is matrix B? That's the matrix with the constants. What are the constants going to be? 5, 2, 8. You multiply these, that's the answer. That's all you gotta do, it's simple. So you wanna take the 1/2 and put it in? Or should I multiply the matrices first and then multiply by the half? Yeah, because you don't wanna introduce fractions, right? Because you guys know how you are with arithmetic. This is 3 by 3, this is 3 by 1, so what's the resulting matrix gonna be? It's gonna be 3 by 1, and then you gotta multiply that by a half, because we're gonna do it later. So, go across the row, come down the column, so that's -30. See, now if you want partial credit, like, no, you know, never mind. -30, 18, and 8. What is that? Oh boy, -4. Okay, go across, come down, -40, 8, 26, and then 8. -6. Go across, come down. What is that going to be? 20 minus 14 minus 8. -2. So if I multiply that by 1/2, what do you get? You got to multiply each one by 1/2. Wait a minute, is it 1? Oh, it's -1/2. Cool. And you get 2, 3, 1. So what's the answer? 2, 3, 1. Remember, what you're actually finding, you're trying to find a point where the 3 planes intersect. So you give your answer as a point, yeah? So that's probably the easiest problem on the whole test. All you gotta do, now, if you get this problem wrong tomorrow, like you did, as long as you multiply these numbers correctly, you can get full credit for that. So, well, Mr. Park, what if I don't get any answer for this one? Then make up something there and show me that you know what to do and you can get full credit. Otherwise, no, otherwise you'll get -8 and -8. You want to get -16 on the easiest test of the quarter? No. That's what I thought. Oh, and since we're on this inverse thing, you know, remember we have this theorem, if matrix A is A, B, C, D, how do you find the inverse of a 2 by 2? 1 over AD minus BC, which is the determinant of A, right? Isn't that the determinant? Okay, here, just write determinant of A. Okay, and then what do? Because some of you did the wrong thing. What do you do with these? You switch the ones in the main diagonal and you negate the ones in the other diagonal, right? Remember that theorem? You gotta know that tomorrow. But actually, you don't really need to know because now what? What did we learn to find how to find the inverse? Replace each element with its cofactor. You know that technique we just did? It works on any degree. So look, replace each element with the cofactor. Okay, these are the negative positions. So upper left-hand corner, cross out the row and column. What's left? Upper right-hand corner, cross out the row and column. C. The bottom left, B, and then the bottom right, A. What's the next step? Transpose it. So the first row becomes the first column. The second row becomes the second column. And then you multiply that 1 over the determinant of A. Yeah, that's the same thing. Yes, that's because the technique I taught you works for all of them. That's why. I'm talking about? And then finally, number 8. Well, for tomorrow's test, we got number 9 to do. Number 8. Okay, here we go. You're gonna see this tomorrow, except this one might be kicked up a notch. Now, if you don't know how to do anything, you can always just grind it out, right? Right? Like, how many people just went across the first row? Well, then what did you guys do then? Window. Jen? Well, generated zeros. Because if you do that, if you go across the first row, it's going to be A times, and you got to go this times this, minus that times that. I mean, it's going to work, but isn't that a lot of algebra? So I think it's better to generate zeros. And it's staring you in the face. Well, Mr. Park, I don't see any ones. We don't need no ones. Because look, they're A's. Okay, keep the first row. What do I need to multiply this by so when you add it to this, you get 0? You really have to think about how. What do I need to multiply A by so when I add it to that, you get 0? -1, but you got to do that to the whole row. Multiply by -1, add. Multiply by -1, add. Multiply by -1, add. See how, oh, it's coming out nice. It's like simplifying, right? Because you get fewer terms. Now what about this row here? What do I need to multiply this by so when I add it to this, you get 0? Same thing, -1. So multiply by -1 and add. Multiply by -1 and add. Multiply by -1 and add. See how this one's way nicer? Less terms. Now after doing all that work, you better come down the first column. So that's going to be what? Is that in the positive or the negative position? Positive. So positive A times A plus B, 2A, 3A plus 2B. Now once you get it down to a 2 by 2, it's simply that times that minus that times that, right? But just, what the heck, just for funsies, let's generate more zeros. No, just for fun. Keep the first row. I'm trying to help you for tomorrow's quiz. Let me test this. Okay, keep the first row. What do I need to multiply this by? So when I add it to this, you get 0. Okay, do it to the whole row though. Multiply by -2, add. Multiply by -2, add. Multiply by -2, so you got to distribute it. Add. See how the b's cancel out and you get A. So now when you compute it, it's going to be A times this minus that times that, but that times that is 0, so it's just A squared, so the answer is A cubed. And Morris, box your answers. That's you, Morris. Just box your answers on the directions you would box. From now on, if you don't box, minus 1, 2, 3, 4. Okay, now number 9, well you guys know it's not going to be on tomorrow's test, but this is like this is the kind where it separates the sheep from the goats. How many people got it? One person. Okay, we're going to take a poll again. Period 3, 1. Period 4, we don't know. Period 6, we don't know. Okay, let's do this. Okay, so we have a determinant. 1, 2, 3, 2x1, 3, 1y equals 0. Find all ordered pairs x and y where x and y are positive integers so that when you put it into this determinant, you get 0. Well, what should I do first? Okay, let's pretend this is a problem on a test. Well, this was on the test like 3-4 years ago. What's the first thing I should do? You want to get a few points, what do? Compute the determinant. Shall we go across the first row? Okay, so 1 times this minus that times that, xy minus 1. Minus 2 times this minus that times that, 2y minus 3. And then plus 3 times this times that minus that times that, so 2 minus 3x. Did I do that correctly? Okay, there you go. You write that down, I give you 2 points. So isn't it better to get -6 than -8? Okay, now simplify this. Like multiply everything out. Xy minus 1 minus 4y plus 6 plus 6 minus 9x equals 0. So xy minus 9x minus 4y plus 11 equals 0. Okay, now here is where the thinking begins. How do I figure out what numbers I can plug in for x and y, and got to be positive integers, so that you get 0? Well, what did you do?
I made it two by two. No, I generated zeros.
Yeah, no, we did that already. I'm talking about this step here. Did you really do this problem? Do I have to take off that one? Let me see them. You did that way. Solve for one of these variables. So solve for either x or y. You did do it. I saw it on your paper. Okay, what do you want to solve for? X or y? Pick one. Most normal people will solve for
X.
y. Well, because don't we normally see like y equal 5x plus 3? Normally we solve for y, right? Okay, how do you solve for y? Put all the y's on one side, put everything else on the other, factor out the y, and then divide. So y equals 9x minus 11 all over x minus 4. Okay, now it's a little easier to see. What positive integer x can I plug in so that y comes out to a positive integer also? It's still, okay, like, what if I plug in 1? 2?
No.
Are you sure?
I'm just throwing them.
What about 3? No. 4, obviously not, because you get bottom is 0. What about 5?
Yes.
Yeah, 6. Yeah, but at least you can do it now. But Mr. Park, this seems kind of a long time. Yeah, so maybe there's a better way. Is there another way to write this? Just say yes. Yes, how? What does this bar mean? Divide. You're going to do this a lot in calculus. Divide. So let's do long division today. X goes into 9x how many times? Really have to think about that. So you get 9x minus 36, subtract. Are you serious? 25. So when you divide this by this, what do you get? You get the quotient plus the remainder over the divisor. You just put it in a different form. Now look how easy this is. What numbers can I plug in for x so that positive integers, so that this whole thing is also a positive integer? Well, just think about it. What numbers can go into 25?
1.
Either 1, 5, or 25, right? So in order for this thing to be 1, what does x have to be? You gotta be joking me, people. If you want this to come out to 1, what do I plug in for x? 5. What does y come out to then? 9 plus 25 over 1. 34. Okay? In order for this to be an integer, then plug in 5, right? This has to be 5. So what do I plug in for x to make it 5? 9, because 9 minus 4 is 5. What's 25 divided by 5? 5 plus 9 is 14. And then, if I want to make this 25, what does x have to be? 29. So if x is 29, plug it in. You get 25 over 25, which is 1, plus 9, 10. And there you go. Those are your 3 answers. So you write it in a different form. No wonder I gave this on the test like 5 years ago. I don't need like 5 or 6 people got it. But at least 5 or 6 people got it. Okay, here's another problem. Write me a 3 by 3 determinant that comes out so that the answer is, give me any number, 25. 23. Okay, go. Okay, give me a 3 by, I think I gave this 2 years ago. I want a 3 by 3 determinant with no zeros now. No zeros in it, where the determinant is 23. Okay, go. Oh, matrix 6 is all the same problem. How would you even do this? What would you do? Skip it. Skip the problem and go to sleep, like you did yesterday. We had the cameras on you yesterday, you know. No, we didn't. Huh? As long as you don't have any zeros in there. You can have ones or you can have fractions. You can have radicals if you want. But you can't have zeros. Okay, here, why don't I just tell you? Watch this. If I do this, 1, 0, 0. Yeah, but you said no zeros before. Just listen. If I put 1, 0, 0, then it really doesn't matter, right? If you expand across the first row, does it matter what numbers I put here and here? No, you can put any numbers. Okay, let's go to why. Why doesn't it matter? Because when you take the 1, you cross out the row 1 column. All that's going to be left is this right here, right? So these numbers don't even matter. So now all you got to do is think: what times what minus what times what will give me 23. There's an infinite number of possibilities. People come up with something. How about 28 minus 5 then? Or you want to go 30 minus 7? Or 24 minus 1? Pick one. Or how about 27 minus 4? Okay, so how can I get this times this is 27? 9 times 3? And then this times this. How do I make that 4? 2 and 2 or 4 and 1, whatever. See, so isn't this equal to 23? Because it's going to, if you go across this row, it's going to be 1 times this, which is 27 minus 4, which is 23. Yo, Mr. Park, you said no zeros. Well, then just get rid of the zeros now. How do you get rid of zeros? Yeah, let's keep which column you want, which row you want to work with. Okay, let's work with the second one. It says, what can I do to this row? What can I multiply this by? So when I add it to this row, don't have any zeros. How about 1? Okay, multiply by 1 and add. Multiply by 1 and add. Multiply by 1 and add. There you go. That's 23. In fact, that's how I write problems. I figure out what I want the determinant to be, and then I do something like that. Okay, lucky for you, that's not on the test tomorrow. I already told you what's on the test. It's going to be 1 through 8 on matrix. I can't believe I'm telling you this. It's 1 through 8 on matrix. Which one did we just do? 5. So if you want additional practice, do those same problems on matrix 6, which I see them there. They're all there. Okay, we're done. Now, you gotta admit, it's not that difficult, right? You have to admit. I guess in order to admit, you gotta actually speak.